Good morning, candidates. How are you? Are you still preparing? Are you ready to learn science today? I'm glad that you are ready. Today, I would like us to revise properties of matter. Properties of matter. And I would like to introduce my lesson by taking us to the classes of reference. Where else were we taught properties of matter in primary school? And I've managed to collect this information from the syllabus, and that in class 4, now grade 4, we learned about floating and sinking. Remember when you collected materials and began to put them in water and saw which one was sinking and which one was floating? Pressure in liquids. You really played with polythene bags and boreholes and polythene bags and squeezed the water out of the polythene bags, and the water was flowing. Sometimes you made holes in tins and you saw which hole threw the water far. That is in class 4. That's properties of matter. In standard 5, we learned the states of matter, the 3 states of matter: the solid, the liquid, and the gas. Solid state, the liquid state, and the gaseous state. Then you've got the characteristics of matter. Yeah. Then you've got the effects of heat on matter. You see, like matter expands on heating and contracts on cooling. That was in class 5. Then in standard 6, boys and girls, you learned about components of air. Components of air. What air is made up of, and then uses of air. Different gases are used for what? Yes, what reason? Then in standard 7, that's where properties of matter ended. You learned the solving solids and liquids. Yeah. The ones we call soluble and insoluble liquids. Solubility test was done in 7. Mixing of liquids, a liquid and another liquid, that's called miscibility test. Then magnetic and non-magnetic materials. Yes, I'll teach you a mnemonic on how to remember magnetic and non-magnetic materials. And then separating mixtures. Separating mixtures. Methods of separation of mixtures. You learned them in class 7. Boys and girls, I found out that in class 8 we do not learn that. And so questions that you get in Kcpe vary from standard 4 to standard 7. Now, I managed to pick questions or select questions from Kcpe papers, past Kcpe papers. Because my board is small, I only managed to get 2 questions, to write 2 questions on this. Remember, science is about diagrams, and so because the diagrams are taking a bigger area on the board, I could not write all the questions here. Now, the diagram below, question number 19 of 2012. The diagram below represents the processes 1, 2, 3, and 4. These are Roman numerals that are involved in the change of states of matter. The diagram below represents the processes 1, 2, 3, 4 that are involved in the change of states of matter. This is the diagram. We've got the liquids and we've got the solids. Then we've got the liquids and the gases. 2 diagrams in one. And we have 1, 2, process 1, process 2, process 3, and process 4. Which of the following correctly represents the processes? Boys and girls, that is the question. Now that takes me to the other part of the diagram, and there's a lot of information that can be gathered here. Now we have our mnemonic to remember, to be able to remember this. Soliga. Everybody say soliga. That means solid, liquid, and gas. Soliga. Say it again. Soliga. So you write soliga that way, and you indicate by the arrows. This arrow represents melting. That arrow represents evaporation. This arrow represents condensation. And this arrow represents freezing. And then there's another large arrow here that represents sublimation. Now, and so that means a solid, for a solid to change to a liquid, when solids are heated, they expand, number one, and number two, they change their states when solids are heated. So what happens here? Heating happens here. Heating happens here. So when solids are heated, they change their states to liquid by a process called melting. I hope you are following. When solids are heated, they change their state to liquid through a process called melting. All right? Then when liquids are also heated, so there is heating here. There is heating. Yes, when liquids are heated, they change their states to gases by a process known as evaporation. I hope you are understanding that. Yeah? So there is the heating, the applying of heat on the solid, and the solid now melts and becomes a liquid. The applying of heat on the liquid, and the liquid evaporates and it becomes a gas. So the solid has changed its state, the liquid has changed its state. Are we understanding that? Number two, when you apply heat on a gas expands. When you apply heat on a gas, it expands, but it doesn't change its state. Gases on heating, they don't change state. They remain gases, but they expand. They occupy more space than before. And so there is one thing that is unique about gases. Now, let's come to this other arrow down here. When we cool a gas, cooling. When you cool a gas, the gas changes its state. When you cool it, yes, it changes its state and becomes a liquid, through a process known as condensation. This is just a reminder, boys and girls, you have learned this in class 7. Then, when a liquid is cooled again, further cooling. When a liquid is cooled again, it changes its state back to a solid, becomes a solid again, through a process known as freezing. Yeah? An example is an ice cube. An ice cube is a frozen liquid. It is a frozen liquid. So when we say, what is a frozen liquid? That's an ice cube. Yeah? It's another new change of state. Now, having said that, there is this process known as sublimation. Now, a solid becomes a gas directly, skipping the liquid state. So sublimation, this process, the solid change to gases, skipping the liquid state. So some solids, not all solids, some solids, they change their state from solids to gases directly, skipping the liquid state. That process is known as sublimation. Have you understood that? So that's sublimation. An example are the air fresheners that are solid that we use in the houses to make the house smell good. We put the balls just in a corner. And after some days, we find that those balls are not there because they sublimed. That means they changed their state from solids to gases directly. That's called sublimation. Did you understand that, boys and girls? That was great. Now, before I come to this other part, I would like to talk about melting and freezing. There is a relationship between melting and freezing. A relationship between melting and freezing. The temperature at which a substance melts is the same as the temperature at which a substance freezes. Did I say something very important? Please allow me to write here. Allow me to write here. And this one you must note down. That the temperature at which a substance melts is the same temperature at which the substance freezes. Get this? And underline melts and freezes and the word temperature. Boys and girls, can you read that again? The temperature at which a substance melts is the same temperature at which the same substance freezes. So freezing and melting happen at the same temperature. So there is a relationship between freezing and melting. Likewise, boys and girls, there is a relationship between evaporation and condensation. There is a relationship between evaporation and condensation. So the same statement can be made for evaporation and condensation. The temperature at which a substance evaporates is the same temperature at which the same substance condenses. So you can write another statement like this one and replace the words melting and freezing. So you replace melting with evaporation, and replace freezing with condensation. So there is the relationship between that. And that is a Kcpe question. Such a question can be asked. I'll just give you that information. So that's another question that can be asked there. Then, before we go to this part, let us answer the questions here. Which of the following correctly represents the processes? 1, boys and girls, 1, liquids to gases, we've learned here. Liquids to solids, we've learned here, melting. So that process is melting. Melting. Thank you. And then, number 2, solids to liquids. solids to liquids, that way. Solids to liquids, liquids to solids, boys and girls, liquids to solids, liquids to solids, liquids to solids, to solids, freezing, freezing, liquids to solids, freezing, the other way around, freezing, and then solids to liquids, melting. Thank you. Then we go to the next part, liquids to gases. Liquids to gases, evaporation, and then gases to liquids, condensation. So back to our choices. Number one, we've written freezing. The arrows, very, very important. The arrows, very, very important. I can't see freezing here. And since I got the question from the booster, Kcpe booster, maybe the arrows were confused. And so we can rectify the arrows, especially here. Maybe that one was that way, and we will wrap that. Then this one was that way. So if this is the case, then this becomes melting, freezing, liquids to solids to gases becomes melting. Some of these books can mislead you. Then, boys and girls, that becomes freezing. Correct. No, freezing. So number one is melting. Number two is freezing. Number three is evaporation. Number four is condensation. So this is correct. That's exactly what it's supposed to be. And so choice number one becomes the correct one. Choice A is the correct choice according to that arrangement. Boys and girls, did you understand? Sorry for the hitch that came about because of the arrows where they point. It's because when of the typing error, the arrows in the booster did not correspond with the arrows in the exact Kcpe papers. And I'm really sorry about that. But well said and done. That is correct. Now I want us to look at this corner. So much information from the same question, same subtopic. Now, increase of temperature. The processes that require increase of temperature are melting and evaporation. These are the processes that require increase in temperature. You know, heat is applied. And when heat is applied, the temperature goes up, increases. So these are the two processes, melting and evaporation. Then these two require decrease in temperature. And they are condensation and freezing. They are cooled. So the heat is reduced, and so the temperature goes down for these two processes to take place. I hope you've understood that, boys and girls. Question number 8 of 2018. So that was about change of state. And change of state is learned in which class, boys and girls? Change of state. Is it standard 5? Correct. Standard 5. Now let's come here. Question number 8 from 2018, Kcpe 2018. In an experiment on mixing of liquids, water, oil, cooking oil, fresh milk, and kerosene were mixed. Okay, what was mixed? Water, cooking oil, fresh milk, and kerosene were mixed. 2 at a time. They were mixed 2 at a time. Yes? Now, they realized that cooking oil mixed with some other liquid that we are not told. We are not told. I want us to go through something else before you answer that, and you'll be able to answer that question quickly. And then, I have noted here that miscibility depends on the density of liquids. Note that liquids of different densities cannot mix. Liquids that mix must have the same density or almost equal density to mix. So miscibility depends on the density of liquids. Come with me to this side of the board and I'll show you something. Liquids are divided into 2. Liquids are divided into 2. The water family, and the oil family. Water and oil family. Liquids are divided into 2. All water and oil family. Things like milk, spirit, water, ink, and juice. Are we together? Are we together? Milk, water, ink, spirit, and juice. I hope I've exhausted them all. These ones are liquids under the water family. I'm explaining why we call them water family. Yeah? It is because they have a similar or almost equal density. Yeah? And so they are miscible. Liquids from the same family are miscible. Now we go to the oil family, where you have the kerosene, we have the kerosene, we have the cooking oil, the petrol, the diesel, somebody called it the DSL, yeah, the cooking oil, the engine oil, These ones are in oil family. We cannot forget to say turpentine. These ones are in the oil family. And so these liquids in the oil family, they mix within themselves. If you mix them all together in one container, they will have one layer. They'll not form layers. There'll be a solution on itself. And the solution formed by miscible liquid is called homogeneous solution. Homogeneous solution. This is a solution formed by miscible liquids, as in liquids of the same family. If it is the water family, if they are mixed together and form one solution called a homogeneous solution. If they are liquids of an oil family alone, they are mixed and they form one layer called a homogeneous solution. But if you mix a liquid from water family with a liquid from oil family, they cannot mix. They cannot mix. They cannot, because they are immiscible. They are immiscible. Liquids that do not mix are called immiscible liquids. Immiscible liquids. And so, for example, if you take milk and mix with kerosene, milk and kerosene, they will not mix. After settling, they'll form two layers. There will be a solution called heterogeneous. Heterogeneous. Let me write it here. The opposite of homogeneous is heterogeneous. They'll form a solution known as heterogeneous. Hetero because they cannot mix. They are forming layers. I hope you do understand. And so, whatever mixtures you mix, boys and girls, if you will take a whole lot of kerosene, petrol, diesel, cooking oil, engine oil, and mix with milk, water, ink, spirit, and shake them vigorously, at the end of the day, there will be two layers. A layer of water family and a layer of oil family. The maximum number of layers to be formed when mixing liquid are two. So let's come here and this question. Now, two at a time. Cooking oil mixed with what? Cooking oil. Now get cooking oil. You will find it in the oil family. So cooking oil can mix with any of these liquids in the oil family. Can we find any of those liquids? Cooking oil, we have water and fresh milk. Water and fresh milk is in the water family. Right there, water family. Then water is in the water family. Fresh milk is water family. Kerosene oil family. Here we have kerosene alone, oil family. It is now obvious, boys and girls, that the right answer is D. The right answer is D, because cooking oil needs a liquid from oil family, and that is kerosene. Did you understand that, boys and girls? Today, I have not had enough time to check on the other Kcpe papers, but I promise in the next science lesson, I must make sure that I do another set of questions on properties of matter. And because that is the second highest set subtopic in science in Kcpe. I hope you all enjoyed that and you can be able to answer Kcpe questions without a problem. I love you all. I enjoyed teaching you. Have a lovely day ahead.